This presentation is based on the Interplanetary Networking Special Interest Group, IPN-SIG, Space Summit Lab. Lab steps were defined by Lee Torgerson of NASA's JPL. Okay, just a reminder, this is a 1 hour lab. I'm going to try to do a hard stop at 1 hour. So if there's a question you ask me and it's out of the scope of what we're going through here, I will answer you separately. If it's a question that isn't specific to your environment only, or I think it's a question that would be interesting to everybody, I will put that question and answer out on your course portal page. We've got a Q&A area. Remember to pop your questions and answers in there so I can track them and see which ones I've answered and things like that. But also feel free to pop some information into chat of who you are, where you're from. And as I mentioned before, I'm recording this. You should have heard the audible on that as well. All right. So in last week's lab, what we did was we did a 1 computer lab and we had communications between 2 instances of ION on that 1 Raspberry Pi. Okay, we downloaded that configuration file called lnodes for local nodes. When we unzipped it, we had 2 folders. We had lnodes 1, lnodes 2. When we ran ion start in each of those folders, we started a separate instance of ion. And we ran bping from one instance to the other instance and got a BP echo coming back. We also talked about the kill command, the kill M command. That's how you shut down ion. If the configuration seems to be funny or you're bringing up ion and it just keeps scrolling with errors and just keeps going like that, just Control C to stop the ion launch. And then you can go ahead and run kill M. Yes, Dana mentioned that ion stop works well also. Kill M, though, will kill a number of the executables that are running. And I'll show you a list of the executables that are part of ion in here. And time permitting, I will actually show you what it looks like. This lab that we're doing, what does the traffic look like? So I have a trace file where I captured this lab. So this is what we're going to be doing today. We've got our 2-computer lab. We have 2 Raspberry Pis, 2 physical separate Raspberry Pis. One should be named rpi01, hostname rpi01. One should be named rpi02, hostname rpi02. The configuration files are already set with those names in there. But when we get into that part of the lab, I'll show you, if you didn't name them this way, here's how you can temporarily change the name so the lab will run. This time, we're not going to be talking to the loopback address. We're going to be talking between one IP address and the other IP address. They're on the network. We're going to download 2 files. We're going to download comp1 iontest.zip onto our rpi01 host and unzip it, and that will give us a folder called iontest where all the configuration files sit. Then we're going to go over to our rpi02 device, and we're going to download a file called comp2 iontest.zip. Unzipping that, we'll have another folder called iontest that has all the configurations for the rpi02, our second node. When we go to the first node, IPN node 1, when we launch ion start in that folder, what happens is it starts up and it immediately, based on the configuration settings we've got in there, it immediately starts trying to make a TCP connection over to rpi02, because our configuration files, and I will show you those, our configuration files for this test are going to be looking for rpi02 out there. So it's going to start making these TCP SYN packets. It's going to send these out to rpi02. rpi02 is not up yet, and so we aren't going to get responses back. We're going to time out and send another SYN, time out, send another SYN. And that's normal as you're waiting for that neighbor to come up. When we go over to the rpi02 or IPN node 2, and we launch ion start to bring up ion, now that second host is up and it would respond to those SYN packets. It also will send SYN packets over to our Pi O1, our node 1. Each host, when we're going over TCP/IP, each host makes a connection to the other host. Each host establishes its own new connection to the other host. We're going to be looking inside of this file, this configuration file called the Bundle Protocol Runtime Configuration file in here, so that you can see how you can change some of the values. Maybe you want to add additional pies to your network and have more nodes communicating. When we run bping, which is the first test we're going to do between these two hosts, you're going to see that we're going to be using this configuration where we have an outduct value. Let me get my drawing tool here. We have an outduct value of rpi02 colon 4557. Essentially, that is the host that we're going to and the port number that we are going to on that target host. On the receiving side here, we will have an induct setting that is set to 0.0.0.0, which means anybody can talk to me on my port 4557. So the outduct setting is saying who we are talking to. The host, you can put in their IP address, colon port number, or you can put in their host name, colon port number, either way. And then the induct is what ports I have open and who I will accept traffic from for that port. And again, you could put in an IP address or you could put in a host name. We just have to make sure these systems know their host names. Okay, question came up here. Is it possible to run multiple instances of Ion on one Raspberry Pi to create a virtual node network in lieu of hosting on separate devices? Yes, that's what we did last week. That was last week's lab. And I've got the recording for that up on your portal page. So in that case, we just had one Pi and we ran the two instances. Now we're going to run on separate physical boxes. So yeah, take a look at Lab1, download the Lab1 document that has the step-by-step instructions, and then watch the video of Lab1 as well. Okay, so when bping goes out, it's going to go out from an outduct that defines the target. It's going to arrive on an induct that defines the receiving port number and who you can receive from. When BP echo responds to bping, because those two go together, bping goes out and sends a bundle ping, and BP echo is what echoes it back. It does it on a separate TCP connection. So we will have a second TCP connection here that is established from the BP echo side, from our node 2. And node 2 will have to be configured with an outduct so that it understands the target is rpi01 on port 4556. We have to have it on a different port number here. And over on rpi01, we have to say we will accept traffic coming in from any host on port 4556. So it's very different, whereas, if you look at ICMP communications, standard ICMP does not use a TCP header or a UDP header. Okay? ICMP sits right after the IP header. And when we have one IP communication going between our hosts, we don't have separate transport layer connections between the hosts like we do here. Why didn't we just use one? Why don't we just echo back on the same port number and IP address combination? You may have different transmit speeds and capabilities in space. And so they are separate, and we can configure the capabilities separately. So we could say that, oh, that's a huge antenna that's sending data up to me. I'm a satellite, and that's such a huge antenna. It's sending at a very high data rate, but I only have this little tiny antenna on my satellite. And so I send my data down at a slower rate. So we have the ability of having different rates going in different directions. So it's quite a bit different when you analyze the traffic. Okay, so these are the lab steps we're going to go through. We're going to hop right into the lab. We're first of all going to download our configuration files. So we're going to connect to RPio1, and then I'm going to connect to RPio2, and then I'm going to download each of their configuration files. In your books, I will remind you what page we are on as we go through the labs. Let me get my document seems to be missing some pages here. Hang on. I've got another lab doc. I must have put them all into that lab doc. Oh yes, feels fatter. All right. There we go. There. Okay. So right now I'm on page number 3 in your labs, where I have the listing of what's going on here. Question, can we specify the induct as only the other pi? I'm going to go through the configuration file with you so you can see how we specify different things. Yeah. But essentially, when you're looking at this configuration, if on the induct there, I put in the IP address, instead of putting in anybody using 0.0.0.0, if I put in the IP address of RPio1 over here, then I would only accept the traffic from that IP address. That's how you can lock it down to who's allowed to send me traffic on 4557. Yeah. And again, we'll look through those configuration files, and they're pretty interesting. The whole thing is really fascinating to work on this. Okay, so we'll download the configuration files. Now, we're only going to assign host names if you don't have two pies that are named RPio1 and RPio2 to start out with, because the configuration files are set to use those names. And I'll show you where that's set in the configuration files if you want to change them later. We're going to obtain the IP addresses of those two pies. We have to have their IP addresses for our configuration files. And we're going to use those the IP addresses in our host file. We're going to update our host files so that we can use symbolic names instead of always putting in IP addresses there. We'll go in to take a look at the BPRC, the bundle protocol runtime configuration files on these hosts. And whether or not we need to edit it depends on whether your names are RPio1 or RPio2 also. Last week, we put in an export path statement also, and we're going to comment out that export path statement. We don't need it with this set of configuration files. Once we've done that, we're ready to start setting up our pies to run the test. We're going to do 3 terminal sessions, 3 terminal windows on each pie. And then in the top 2 windows, we'll start ION and we'll start our log file viewing in those top 2 windows. The third window on each one of the pies is where we're going to run our tests from. Today we're going to do bping. So we will do a bundle ping to make sure we have connectivity. And then we're going to do bundle streaming today. So we're going to use this combination of BP driver and BP counter. I'll show you both of those and what your options are for configuring that. And then we'll do a file transfer. I'm going to do a file transfer going one direction, and then I have an extra credit for you to do a file transfer going in the other direction. I've embedded a couple of files in the configuration zip files, so you can do that easily. All right, it is lab time. So I'm going to bring over my RPio1 here to start with. And in your books, I'm on page number 4. So I'm going to open up a terminal window. And hopefully you know that these commands are run in a terminal window from our last week's session. I'm in my home directory here, and I'm going to type in wget dash, and it's a capital O there. And I'll move my cursor away. comp1 iontest.zip quote https:// bit.ly/ C1F dash ion test, end quote. All right. So I just did that on my RPI-01. Downloaded that, that's successful. If you get an error in this download process, it would mean that for some reason that drive is not available. It's a Google Drive. You can see what the bit.ly link is actually sending you to. There's the full link without bit.ly. So if you're getting blocked because your organization doesn't allow bit.ly communications at all, then you could go ahead and pull this right off of here from a system that does. Okay, now I'm just going to unzip that file. C1F, sorry, unzip comp1 ion test.zip. So when we did that last command, the first thing we were doing is wget-o, and then comp1 ion test.zip is what we want to call the file when it is brought down to our drive. So I'm going to unzip that, and you can see it made a directory called comp1 ion test, and below that it made another directory called ion test. And here are the files that are in that ion test folder. You can see there's our ion start. And then you can see we've got some configuration files in here. And again, we will look at those files. Okay, so I've got that one set up over there. So now I'm going to bring up RPI-02. And I've changed the background on RPI-02, so you can see a difference between my two Pi instances here. This is RPI-02. I'm going to go out. I'm going to go wget-o comp2 ion test.zip quote https://bit.ly/c2f-ion test. Okay, so it's downloaded the configuration file. And now I'm going to unzip comp2 ion test.zip. And just like on node 1, on node 2, we have a directory. This time it's called comp2 ion test. And below that, we have our ion test folder. And in that folder are the configuration files. And there's a graphic file in there, as well as ion start. Okay, so now we have the option on page number 4 to temporarily change our host names. So if you didn't name your hosts RPI-01 and RPI-02, you could, let me see if I can pop this guy there. You could temporarily change the names on these so that the lab will work. So the instructions to do that are on page 4. And I'm just going to line this up a little better so I can have the two Raspberry Pi screens side by side. I'm going to type in clear, both of these there. Okay, keep in mind that if you do this command, sudo hostname RPI-01 or sudo hostname RPI-02, it's temporary on the Raspberry Pis. All right, but I need to get the IP addresses of both of these. So it's ip.addr. And there is my IP address on RPI-01. 10.0.0.241 is mine. And then over on RPI-02, IP /addr. And my RPI-02's IP address is 10.0.0.226. So you'll need to write down the two IP addresses that your pies are using. And now we're going to go into our hosts file, our host files. I'm on page number 5 in the lab workbook. Okay, so over on RPIO1, get rid of my drawings there. Over on RPIO1, you can be in any folder to do this. Sudo nano /etc/hosts. We're just going to go in and edit our hosts file. These are the default entries that are in there. And then at the bottom of this, I'm going to add an explicit value for RPIO1. For me, it's 10.0.0.241, RPIO1. And then I'm going to put in RPIO2's IP address in here. And the reason why I'm doing this is just because the configuration files use the host names in them instead of just IP addresses. And 226 is the IP address for my RPIO2. Likewise, I'm going to go over here to RPIO2, and I'm going to sudo nano /etc hosts, come down in here, and basically do the same thing, focusing on RPIO2 as the local host. 226, RPIO2, 0.0.241, RPIO1. All right. So each of my systems has a host file that has the IP address of the other Pi, as well as its own IP address explicitly in there. And then to save this in Nano, we Control O, then hit Enter, and then Control X to get out of Nano. So I click over my hosts file on RPIO1 here, Control O. Let's try this again. Well, that's interesting. Let's see what's going on here. Well, that is not working. Let me bring up this window again and see what I did here. So it could be from leaving that window, going out to another Pi while leaving that file open. So I'm just going to pop this back in. Sudo nano etc hosts. Come down here. 10.0.0.241 is my RPIO1. 10.0.0.226. RPIO2. Control O. You know what? Okay. All right, so I had an issue here with this one where Control O is not working on this Pi. So here's what I'm going to do. I'm going to close that window down, and I'm just going to check the settings on this Pi. I'm going to go up to the little Pi icon, go to Preferences, go to the Control Center. And I'm just going to look at my keyboard settings in here. It's set fine. So I don't know what its issue is. But here's another thing you can do. You have a file manager inside, and depending on what files you're going to try to edit in here, you could possibly go into the file manager program and do the edits with the file manager inside of here. You just have to get down to the host file and then open it up inside of here. Okay. But here's what I'm going to do. Because that Pi shouldn't be acting that way, I'm going to reboot that Pi and connect to it again. It just makes me concerned. And we've had some issues with this Pi. And it's strange. We have a power supply that is a little glitchy on it. And earlier today, it just stopped talking on the network completely. Even though it was up and functioning, we had no idea anything was wrong with it. But we get a notification every once in a while on that Pi saying, you don't have the full 5 volts required for this Pi to function properly. So I'm going to go ahead and just sudo reboot now. There are not 2 control keys on this keyboard now. This is just regular. Yeah, it's really strange. So if you get a Pi that just starts acting strange and it's just so hard to tell, it's just strange. Yeah, sometimes VNC doesn't like special keys. Yep, this is in VNC though also. We do all of our configurations in VNC and we just don't usually have an issue, but I'm going to go ahead and connect to it one more time. Oh, I've got VNC up here on my other monitor. And let me bring it over. Okay, so here's 241. It's up. I'm going to go ahead and connect to it. There. And let me just pop this guy up on the left-hand side again. Yeah. Oh, come on. You know what I want. There. And then on the right-hand side, I actually want my... There we go. Okay. Let me pop back in. See if that has fixed the problem. Okay, sudo nano etc hosts. Pop back down here. 10.0.0.241 is this pi 1. 10.0.0.226 our pi 02. Control O, enter, Control X. Yeah. So I just restarted it and that seemed to clear whatever that weird problem is. I noticed this earlier when I was doing just a test connect to it before the class that it seemed to have some issue. And it's that, I tell you, it's that power supply. So now when today's class is over, then we're going to swap it with a good power supply, let it run for a while, see if that type of problem keeps coming up again and again. Then we'll know it's the power supply. Okay, so we've gone through step number 3 and we are now on step number 4. Now we're going to go in and edit one of the configuration files. As I mentioned before, how these inducts and outducts work. If I'm on Raspberry Pi or node 1 and I want to talk to node 2, my outduct points to node 2, the target. The induct is the port that I'm going to have open and from whom I will accept the traffic. So page number 6 in your books talks about this BPRC file and shows you what the file looks like. If we want to go in and take a look at it, I'm going to go to the proper directory. I'm going to go into my comp1 ion test folder. And underneath that is the ion test subfolder. Inside of here, there's my BPRC file right here. Now you only need to go in and edit this if your host names are different. This file is already configured to use the names rpi01 and rpi02. But if yours are named differently, you'd have to go in here and edit it. So I'm just going to take you into this file. IPN1.bprc, BPRC. Here's the file. So the endpoints area in here is basically talking about what services I'm going to have active on this host. So this host, my rpi01, is IPN node 1, 1.0. You could think of that 0 as almost being a port number. .1, .2, .3. So these are all the listening services, listening service numbers. Okay, and then down below that, if you use your arrow key, down arrow key, to go all the way to the bottom of it, you'll see there are protocols and ducts. The protocols that we're going to be using. All right, so we have the bundle protocol, which is a bunch of data gets put together as a bundle. That bundle can go over UDP, it could go over TCP, it can go over other transport layers. But we need something between the bundle and the transport layer. We have this convergence layer, it's called. It's like a little shim that sits underneath the bundle protocol and TCP or UDP or whatever transport you've got. So wherever you see this CL value, that's the convergence layer. That's the piece that's sitting between the bundle and TCP or the bundle and UDP. So here we have an induct on RPI01. We have an induct that says the protocol I'm going to use is TCP. I will accept TCP packets from any IP address coming into port 4556. And this induct is my TCP convergence layer induct. I have an out duct that I'm setting up here, saying I want to use the TCP protocol. I'm going to be going specifically to RPI02 on port 4557. We don't need to declare the name of the out duct. So that name isn't required at the end. And down below that, you will see that we have plans. These are our plans. Who we're going to be talking to, on what port, and what their IPN node number is. The next command we have below that is where we're starting those watch characters. Hey, Raul, you said you have the same warning with the 5-volt every time you turn on your Pi. Yeah, and these are really cheap power adapters that we got for the Pis here. I just like them because they have a button for power on, power off on them. And we only have a couple of them that have that issue, but I would be interested to hear if you also see unusual behavior with your Pis where they suddenly just sort of drop off the network and things like that. Be interesting to know. Okay, and then the last thing that you see in here is just the starting of the daemon. So you only need to go into your BPRC files and edit them if you have used a different naming convention, host name convention. In that case, I'd have to change this value from RPI02 to whatever the real name is of that second system. I've got both of mine configured with RPI01 and RPI02 so that they're set up for the lab. So I don't need to edit anything in the BPRC file. But it's good that you know about that file. If this were a 1-week class, we would go into every line of every configuration file. All right. In your books, in your lab workbooks on page number 7, you'll see the steps I just did, which is where I just opened up that file. So if you have to, the instructions are in your lab workbook on page 7, the top of page 7, the end of step 4. All right, so step number 5, we're going to comment out the export path statement. We don't need that based on the way this was configured. So from our home directory, not in your comp1 ion test directory or comp2 or the standard ion test folders, not there, but be at your home directory. And if you move to another directory, let's say I move to comp1 ion test, to get back to your home directory, you can just do a cd space tilde, and that will always take you back to your home directory. Okay, so I'm going to type in nano.bashrc. And here I'm going to use a down arrow. I'm going to go all the way down and remove that well, I'm not going to remove it. I'm going to comment it out. This last line, this is the one we added last week for the 1 pi using the loopback test. So I'm just going to put in my pound sign in front of that, Control O, write it, hit enter, Control X. Yes. Thanks, Sable. You put in another variation of that command. There are so many different ways to do different things, and depending on where you are in the directory structure, if you guys have any hints and tips for other folks, pop them into that chat window. That's great. Okay, once we go through that one, I'm going to pop over to this one. No, I'm going to go ahead and finish up with this guy on RPI01. Now what I'm going to do is I'm going to do a source.bash rc, and you will see that that is at the bottom of page number 7. We're in step number 5. Okay, and you're going to want to do that on each system that was configured for lab number 1. So I'm going to pop over to my RPI02 system, nano.bash rc, go all the way down to that export. There we go. Just comment it out. Control O, enter Control X. And then source.bash rc. There we go. You can type in print env to verify that you don't have that statement in there. But here's the problem. It's not going to be removed from this list until you restart. So you may still see it in there, but as long as you have that exclude, if you've got that pound sign in front of it, it won't be run. Okay, let me go ahead and clear. So I've removed the export path statement, and now I'm ready to run some tests. All right, so first thing I'm going to do is I'm going to set up 3 windows here, 3 terminal windows on each of the pies. I'm going to make another one here. Now, if you end up doing a lot of this type of work, take a look at the tool called Termius. I'm going to put its name. I'm going to put this into the chat. Okay, we use Termius when we're doing a lot of work that deals with terminal windows, because you can run scripts, and that's the way we configure all of our pies at one time in here. We just run through a series of scripts, and it brings up all of the pies with the latest version of Ion. Makes it just super simple. Hey, a new version of Wireshark came out. If you didn't get a notification on that, like I just got mine popping up in the background, there are quite a few changes that are significant to Wireshark. You want to read the what's new. Okay, so I'm going to set up my third one. Okay, the top window there is going to be the one that I run Ion Start in. The second window in each one of these is going to be where I look at my log file entries. And then the third one is where I'm going to run my commands to do beeping and to transfer the file and to do the streaming. And we're going to watch those watch characters also. Okay, I'm going to bring this guy up. Now, also, if you do use the terminal windows a lot, you can set it so that every time you open a terminal window, it opens to a certain size and with a certain font size. You can go into your edit preferences on the terminal windows, so they all come up every time you open them to be the exact size you want. Okay, so I've got my 3 terminal windows set up. That's what we see on page number 8. And now what I'm going to do is in each one of these, I'm going to go into my comp ion test, whether it's comp 1 ion test on RPI1. It's not going to paste it there. I thought this one was set up to do paste with just grabbing it there. It is not. I'm going to get rid of that. Don't want that. So, okay, I'm in that folder and cd comp 1 Now, being that I'm a packet analyst, I would probably have a fourth window where I'm doing packet capture on one of these. And I would just go ahead and capture with TCP dump and then bring it over to another machine to do the analysis. I wouldn't do the analysis on these machines. And the reason is the install version of Wireshark on Raspberry Pi OS is an older version and it doesn't have the latest dissectors for ion traffic. Okay, so I've moved into my ion test folder on each of these, and I'm ready to go ahead and run my first test. So step number 7, we're going to start up ion on the top window of each of these. Middle window, I'm going to set up viewing of the log. So chmod plus X, make it executable, ion start, and then dot / ion start. That looks good. Great. Now, at this time, RPIO1 is sending TCP SYN packets over to RPIO2, but it's not getting responses to any of those because I haven't brought up RPIO2. So I'm over on RPIO2 now. Chmod plus X, ion start, dot / ion start. Okay. Now, RPIO2 is sending a TCP SYN packet over to RPIO1, and it's answering RPIO1's TCP SYN packets with SYNAX. Second window, I'm going to go down on the left-hand side on RPIO1. I'm going to type in tail-f ion.log. And I can see in this log file, if I look up there, I can see whether or not they're connecting to each other. Connected to socket, TCP socket 10.0.0.226.4.5.5.7. We can see that IPN node 1 can see IPN node 2 and it's connected to it. That's all in the log file. So over on the right-hand side, tail-f ion.log. And we can see on the right-hand side that it sees IPN node 1 as well. And now let's run our connectivity test. So step number 8, we're going to run bping from node 1 to node 2. BP echo is already enabled in the configuration files, so we don't have to type in BP echo over here to echo back the pings. So on node 1, I'm going to type in bping, and I'm in your lab doc page 9. I'm in step number 8. bping-c1, just going to send one ping packet, -q0, don't wait, send it right away. Send it from IPN node 1, service number 2, to IPN 2, IPN 2, node 2, service number 3. And if everything works well, when I hit enter here, we should see the watch characters up above. The sender BC, YZ is receiving. And over on node 2, we should see YZ receiving. And then we have the start of the application, the BP echo, and the bundle protocol created and then sent. On your course portal page that we made, that has the cheat sheet in there with all the watch characters listed. So our ping is running great. bping is running great. We have connectivity between our two hosts. If you have an issue, something didn't work right there, make sure that you are working with a clean Pi. In other words, if you had lab number 1 running on your Pi and you didn't do kill M, you didn't restart the Pi, consider rebooting the Pi. All right, in the bottom of page number 9, there's a mention there that if you're interested in the parameters available for bping, you can just type in man space bping to see the parameters. And that is true of each of these commands that we will run. So now we're going to go on to step number 9, page 10. And I am now going to do a stream. I'm going to send I'm going to stream bundles from node 1 to node 2. So we start with the receiving end. We need to say that we are ready to receive this stream. So over on the right-hand side, the third window down here on my rpio2 host, I'm going to type in, and this command is on page 10 in your books in step 9, BP counter IPN :2, node 2 on service 4, 1,000 bundles. I am setting it up to receive 1,000 bundles. And I'm going to hit enter. And now it's just going to keep telling me how many bundles are received. It just keeps piping up on the screen telling me. And when I start sending bundles from the other side, I should start seeing the bundles received value increase. So on node 1, I'm now going to use BP driver. That is what sends bundle streams. BP driver, I tell it how many bundles I want to send. I want to send 1,000 bundles from my IPN :1.4. I'm node 1. I'm sending it from service number 4 to IPN :2.4. And then what size bundles do I want to send? We do a hyphen and then the size in bytes. And it wrapped on my screen. I did not hit enter. And now that I've typed in that 10,000 value, I'm going to hit enter. And look at those watch characters go. The watch characters up above, the B's and the C's. The B's are the building of the bundle. The C is the transmit of the bundle. The Y is that receive of the bundle. And the Z is the processing, handing it up to the app on the right-hand side. Awesome. So this is not an echo back. Okay, having some issues running tail on rpio1. It was working last week. Had the same issue, was not creating the file. Restarted the Pi, fixed it. Yeah. You know, we hit that so many times. We're just restarting the Pi. If we had weird behavior, we just restart the Pi. And so usually when we're going to do a class like this, or we're going to do a lab dealing with our Pis, we'll just stop for a moment, do basic B-ping testing, just to see if everything looks like it's sort of working. And if we have any sort of strange behavior, we just immediately reboot the Pis. All right. Okay, on my right-hand side, I can see that I have received 1,000 bundles and the time elapsed and what the throughput is. So we've done some tests in our lab here where we've actually injected delays and packet loss along the path. And at some point, if you're interested in continuing and doing additional labs related to ION and staying involved in this, we'll do some more labs talking about how to set up a 3-node system, and the center node there is injecting delays. Yeah. Oh, this stuff is so cool. There's just so many things that I wish we had tons more time. But if you want to do more labs, things like that, let Karen and Richard know from WASTC. Let me know, and we'll schedule some more labs moving forward. Just keep building it out. Okay, so we've done our streaming. I have a note on page 10 on the bottom just saying if you want to know more about BP driver, you can just look at the man page. And the last thing we're going to do is we're going to transfer a file. Just like with streaming, we have to set up the receive side first for this. Then we set up the send side. So we go over to our rpi2 and we type in BPCPD. Let's type it in correctly. BPCPD. This is the bundle protocol copy daemon. Hit enter and you won't get any verification that you've done anything. I wish they would give us some validation saying, hey, BPCPD is running, but it doesn't. And now over on the left-hand side on my RPI01 system here, I'm going to go ahead and clear and show you that in this folder, we have a file called dna.png on RPI01. And that's the file that I'm going to send across to RPI02. And at the time that you send it, you can change the file name during the send process. So I'm in step number 10. I've done BPCPD on RPI02, the receiver. Now on the sender, I'm going to type in BPCP, the name of the file, dna.png, and then the node that I'm sending it to, the colon, and then what the file name should be. DNA exfer, let's say. Excuse me. So when it goes over to and is sent to RPI02, node 2, it will be named DNA exfer.png when it arrives. I'm going to hit enter. There's our watch characters. You can see the queuing, the transmit. It says complete. And if I come over here and just do a Control C to stop my BPCPD on the receiving side on node 2, I'm going to do an LS, and there I can see DNA exfer.png. It's there. What would happen if you set up the sending side first and then the receiving side? Okay, well, let's just try that. I don't have BPCPD running on my RPI02 right here, my node 2. And so I'm going to go over to node number 1, and I'm going to do the same thing, and I'm just going to say DNA exfer2.png. And I'm going to start saying I want to do this transfer. You'll notice that these packets, the watch characters are telling you that the transmit is going across the network here, but on the receiving side, you'll see the watch characters indicate that they're being dumped here. Well, actually, no, the queue means they're being queued up on this side. So now I'm going to come over here and do my BP CPD for the receiving side. I'm just going to let it run for a moment because if it is truly queuing, it would then be received. Hit Control C. Oh, sorry, clear, LS. And there's my transfer 2. Now that gives you a feel for what ION and DTN is all about. This concept of store and forward, that things can be stored before moving on. In that case, I showed you what it's like when I'm just, the stack is receiving stuff, but it's not sending it up to the application yet because the receive daemon hasn't been launched to pull it out of the buffer and send it up there. So it's really interesting how it behaves. So different from standard TCP/IP communications, what we're used to. Okay, in your course lab notes, I have an extra credit on page 12 for you to do whenever you get time. Try it out. I want you to transfer files in the opposite direction. And you can transfer all sorts of files. And I would like to see you capture the trace files and take a look at them. Okay, so now what I want to do is very quickly here, I'm just going to wrap up because I know we're getting towards the end here. I am going to move my windows out of the way for a moment, get back over here, and just show you, I wanted to just bring up ion start to show you what ion start is. That ion start, when you run that script, that's basically saying, I want to run this ion admin executable using this configuration file. Ion sec admin using this file. LTP admin, we've got it commented out for this lab, but here's the configuration file that it would point to. So you can see that BP admin is what goes and looks at IPN1.bprc, the BPRC file. Ion admin is launched again. Look, it's launched up here to pull this file of this set of configuration files, but then it's run again to pull this other file called global RC. And then at the end of Ion start, it launches BP echo so that we don't have to type that in on the receiving end. Let me clear this. Okay. This slide shows you the standard set of Ion configuration files and what's in each one of these files. If you're looking for indux outdux, you're looking for BPRC files. You're looking for those BPRC files. If you are looking for things like ranges, the connectivity stuff, you are then looking at an RC file, an Ion RC file, or something else that will end with RC. And I want to finish up with this video showing you the difference between TCP/IP communications and DTN communications. So this video is available online, and I'm just going to play this. The first thing you're going to see is file transfer over a standard TCP/IP network. The second thing you're going to see in this short video is file transfer using DTN. So in using standard TCP/IP protocols, communicating from the astronaut down to the ground station. As we move across in time, we can't transmit until we have a link to the target. We have a way that we know to get to that target. And so we would have packet loss in this case. So with traditional IP, we need to have that complete path available to us. But this is the way it works in DTN. Only the next hop along the path needs to be available. So it can send right now because the habitat is available, relay 1's available, great, but now relay 2 is not available. It's gone on the other side of the moon or something. And you can see how this store and forwarding system works. I think this is just a great video for showing how that works. It's such a simple video, simple concept. I've done a billion slides on that, and my slides are never as good as that video is. All right, this is the last slide I'm going to show you here, just ranges and contacts. I'll give you a copy of these slides. I'll upload those as well. In that lab that we just did, we had to tell node 1 where node 2 is. And the way we do this is in the global RC file. If you look at your global RC files on ARPANET-1 or ARPANET-2, you'll see these lines in here. The range basically says when I can start sending to that neighbor and when I must stop sending to that neighbor. So maybe they are no longer visible to me. Orbital dynamics, we know when things go behind a planet, things like that are unavailable to us. We just put in the node numbers, and I've got the listing down below, my little cheat sheet area here. This is my legend of what these are doing up above. So there's adding a range. Start time is right now when you do a 0. Then you do end time. You can also do it in seconds. You could say 20 seconds from now. It's not going to be visible. So that's as long as you can talk to it. I've got an entry here for traffic going from node 1 to node 2. I've got another entry for traffic coming back from node 2 to node 1. These values should be the exact same on both nodes. And then the last thing is the one-way light time to get there. What is the delay to get there? The contact has similar entries, but at the end of it, the last thing is the transmission rate. Contact defines the transmission rate. So if you look at these two files on your node 1 and node 2, you'll see that they are identical. We've got same bidirectional delays and things like that, so we don't worry. Thanks, everybody. I appreciate your time. Dominic, I'm going to answer you offline on your question. And if anybody has any other questions, remember that you can reach Scott and I anytime. We're happy to answer any questions. Okay. Have a great Friday and weekend, everybody.